In this exercise, we have a function y equals f of t. So this is a t-axis. They give us a function y equals f of t. So the graph is given. And they defined a new function g of x as the integral of f of t from -5 to x. So x changes until the integral becomes g of a function of x. So they want us to find g of different values. Okay, so what that means is, let's say if you want to find g of -1, you'll be calculating from -5 to -1 of f of t dt. So that's what g of x looks like. G of a number is the integral from -5 to that number of f of t dt. So I'm going to clean this up and then see if we can do the problems. All right, so first one is g of -3.5. This is the integral from -5 to -3.5 of f of t dt. Okay, so -5 is here, -3.5 is here, so we want to find this net area. And this is 1.5 unit by 3 units. So the area is 3 times 1.5 times 1/2. Because it's below the x-axis, so the integral is the negative of the area. So that gives us 1.5 squared is 2.25. So this value is -2.25. Okay, clean this guy. And we're going to continue that way to calculate the other ones. G of -1 is the integral from -5 to -1 of f of t dt. So -5 is here, -1 is here. So we want to find the net area from -5 to -1. And one thing I kind of see is this little triangle has the same area as that little triangle. It's a half by one triangle, and one is negative, one is positive. So when you add them up, they cancel out. So what we have to do is calculate this area, which happens to be 2 because it's a 1 by 2 rectangle, and calculate the area of this. And we're going to subtract this area from 2, from this area. All right, so this is a 1 by 3. So I will calculate this little square first. That's a 1 by 1 square, so that's 1. Then the next one is a 2 by 1 triangle. So that is 2 times 1 times 1/2. And this is 1, so this gives me 2. So this area, the whole thing is 2 units. So this integral is -2 plus whatever that 0 is. It's a 1 minus 1/4 plus 1/4, but it's a 0 plus 2, which happens to equal 0 also. So g of -1 is 0. Uh-oh. No. I just want to eliminate this and this. Okay. All right. I didn't want to. Okay. Now let's calculate g of 2. G of 2 is up to this point. The integral up to this point. We already know that the integral up to this point is 0. Okay, so that's this plus that is 0. So what we're going to calculate is the area of that one, and that will give us what we want. Okay, so from here to here. Let's see, let's break it into little pieces. That's a 2 by 2 square, 2 by 1 square, and that's a semicircle of radius 1. So pi r squared is pi times 1 squared, but half of that will give me pi over 2. And this one is a 1 by 1 triangle. So the area is 1/2. So that gives me pi over 2 plus 5/2. So that's pi over 2 plus 5 over 2. And the last one is g of 6. So to calculate g of 6, let's use 6. So from -5 to 6. The integral will be this negative area, this positive area, and this negative area. But up to here, we already got this guy. Okay? So what we're going to do is find the area here and subtract that from this guy, because this is below the x-axis, so the net change is negative. All right, so let me see if I can clean up a little. And now this is a 4 by 4 triangle, so it's 1/2 by 4 by 4. That's 8 square units. So this integral is -8 units. So what you get is pi over 2 plus 5 pi over 2. 5 over 2 minus 8. This is 16 over 2, so it gives you pi over 2 minus 11 over 2. So g of 6 is pi over 2 minus the number 11 over 2. All right, this is a negative number, but why is it negative? Because the area under the curve, under the x-axis, is bigger. So this and this in aggregate is bigger than the area above the x-axis. And so that's the answer.